This video is about moving averages. The moving average operator performs calculations on series data. As its name implies, it can calculate moving averages, but it can also calculate minima, maxima, counts, standard deviations, and more. The operator performs its calculations on a configurable number, a window of examples, for a single selected attribute. This video combines calculations on multiple attributes using different calculations and with different windows, with all the results appearing in a single example set. This makes it possible to see all the results easily. Now, to do all of this, the loop attributes operator combined with rename by replacing is used. This is in combination with the moving average operator itself. One benefit of the approach taken actually is that all the input attributes don't need to be known ahead of time, so it's very flexible. So what we'll cover is we'll look at some series data initially, then we'll look at the loop attributes operator, which selects attributes to process one by one, then moving average for different functions in different windows, then rename by replacing, which you need to use if you want to combine multiple calculations into one final example set. And we'll also look at other parameters to the moving average operator, probably not in this exact order. We'll look at them as we get to them. Let's look at some data. So a simple process, it makes some data. It happens to read a CSV file which contains share data for the Ford Motor Company since 1972. I've taken the trouble to plot an advanced chart of this. Basically, it's got 6 attributes which are of just regular type, but they happen to be real numbers: open, high, low, close, volume, and adjusted close. These are things that share dealers understand. Open is clearly the opening price, and that's the blue line here. Date, plotted along the bottom, is of type, it's a roll ID, and you can also see I've also plotted the volume in red with a different axis here. So people that know about shares know that these things are interesting. I don't, so I ignore this. But anyway, it's genuine series data, so I'm going to use it in this and other videos later. So let's go back to the first operator, loop attributes. So what this will do is loop over all of the regular attributes. I haven't selected the special attribute, so the date one will not be considered. Each time the loop attributes operator executes, the macro loop attribute will be set to the attribute under consideration. So what will happen is this loop attributes operator will go off 6 times, and it will call these 15 operators to do various calculations. What I've basically done is I've combined moving average for different windows and different aggregation functions, and let's look at them one by one. So this first one is calculating the average of 20 points. We're going to keep the original attribute, whatever it happens to be, this macro value here, and for now we're going to not worry about the end position and window weighting, nor ignore missings. So this will calculate a moving average of the last 20 points. This next one will do the same, but won't use the average function. It will use maximum. This one will do minimum. This one will do standard deviation. So if I set a breakpoint there, what we expect to see is 4 new attributes created for one of the input attributes, and the name of is not known. It's driven solely by the macro. So let's run that. So we see 4 new attributes have been created, and they are based on the open attribute, which is this one here. And so let's focus on the average ones here. So you can see the name of the new attribute is based on the function that's used to perform the calculation. You can see that's pretty obvious from these names. For this one here, this average is derived from the previous, in this case, 20 examples. If I cut and paste those into a suitable spreadsheet program, which I've done here. Here is those 20 rows pasted into Excel, and by the magic of Excel it's doing an automatic average of those, and you can see 65.272. remember that number. Sure enough, it's that value there. So what the average has done, what the moving average has done, is calculate, based on the window size of 20, the previous 20 including the one that it's on. So it's these 20 here. You can see the 20th point is there. Now let's quickly look back at, if I set a breakpoint here to make it a bit clearer, if I set this to start instead of end and run it again, you can see the difference that the result position calculation makes. So now the average is calculated, it's the same value and it's the same 20 data points, but now it's performing the calculation in such a way that the average is placed at the beginning of the data points. If we were to scroll all the way to the far end of the data, up to the present day, you can see now that obviously this point here has been calculated on these 20 here, and clearly the most recent 19 data points are missing because clearly that's the way it's set up. If I go back to here, if I change this to center, run it again, this time we see that again it's the same average value, but this time it's taken it on the 20 either side, sorry, the 10 or so either side of the average value. So I'm going to guess it's those 20 points there. So in general, it's probably best, if you're trying to predict the future, try not to create an average which depends on the future. In that case, always use end in order to create an average that has no influence from the future, which is what this is showing here. Okay, so let's take stock quickly. So these 4 moving average functions will calculate different functions as it happens. We're going to now understand what this rename by replacing operator is going to do for us. So if we didn't have this rename by replacing operator, and if I then called other moving average operators here, but in this case you're seeing different window widths, it's the same calculations, the only difference is this window width, then what will happen is that a new attribute will be created that will be exactly the same name as the attribute in this first operator here, and that won't work. So what we have to do is use rename by replacing to do a bit of gymnastics to get rid of the names to make them a bit easier to understand. Here's a rename by replacing. This uses irregular expressions, so it looks hard but isn't actually that bad. So what we'll do is I set a breakpoint immediately before this operator and immediately after. We can get a bit more insight into how this is behaving. We'll look at average open. I'm going to copy that attribute name. What this operator will do is rename using some sort of regular expression to pick bits out of the attributes it's found and then create a new attribute name. And the best thing to do is for me to bring up this comment operator. So by using this, we can see this is the name of the attribute before, this is the regular expression that we're going to try and understand. So, and this is what the end result will be. So if I put it all into one place, we can hopefully understand what's going on. So what this regular expression is doing is basically got a so-called capturing group, which is what this first bracket is here, and it will then say find me any character, then find me an open bracket. So in other words, any character any number of times, so that will match anything up to and including this open round bracket. This open round bracket then matches this bracket here, then the macro value loop attribute, which in this, the first one will be open, gets matched here. Then here is another closing bracket, which is this one here. And then the final capturing group, parenthesis, is this last bracket here. And then dollar means end of line. So in other words, anything that matches something and then the attribute name in brackets is turned into a capturing group, which is what this $1 means. So when the replacement happens, it will essentially use the value of the captured group, $1, so average, in this case average brackets open, and it will use that and then append underscore month on the end. So the end result of this should be average open underscore month. So if I run that, it will break immediately after rename by replacing, and we should see the result of that. And sure enough, there's average open month, and because it's very flexible and general, it basically matches any of these attributes: maximum open month, minimum open month, standard deviation open month. All good so far, and now we can proceed with the other moving average calculations, which is what these are doing here. And again, we're going to have another rename by replacing. In this situation, the moving average window is set to 110, which is like half a year. So the rename by replacing is going to use half year as the replace by target here. And then finally, we'll do the same thing again. So we'll do moving average, average, maximum, minimum, standard deviation. This time 220 as the window width, which is like best part of a year in terms of working days. So now the rename by replacing will be whatever the attribute name is, followed by year. Okay, so let's simply let that run. So I'm setting a breakpoint now. This is the first run for the first attribute that it encounters. And you'll notice it's done 4 with a window width of 20. And it's correctly renamed the attribute. Then it's done another 4 for the half year, and this time there are 110 missing. If I scroll down, we'll eventually get to the 111th, which is about there. There we go. And then over here there are 4 where there are 220, actually to be precise 219 missing values. So that's the first attribute. So by running the loop attributes to completion, we will get, for each of the individual input attributes, we will get 12 new attributes created in the output. So there are 6 inputs. 6 times 12, 72, plus of course the original 6, meaning 78. So when I run the process to completion, we should get 78 regular attributes. Sure enough, there we have it, with one special, which is the date. So it's instructive now to start plotting these. So if I plot date as the domain dimension, and let's for fun, let's put the average opening month price. So you can see that there. And if we can now add in things like, let's put in the average open half year price on the same axis. Let's change things to make it show up a bit better. So you can see, sure enough, there's an average going on here. The average always it's done at the end of the data point, so therefore it's always going to be appear skewed depending on the direction of the preceding points. Let's do average open year as well. Let's put that in. Always seems to come up in yellow, which means it doesn't show up very well, so I'll change that to be green. Oops, missed it. So there you go. I can zoom in on these points here, for example. So you can see different averages have now been plotted, and then you can start to have a bit more fun. You can now start to put some of the minima and maxima in, all plotted on the same graph. So for example, let's change the let's put maxima and minima in instead of half year values. We'll zoom in, and you can see now that the average should always be between the minimum and maximum. In fact, what you can do is, if I change the order like that, you can now see, so minimum, I ought to change it even, let's do it properly. There we go. That's better. So now you can see here is the average, which is the blue line, and the minimum and maximum for those data points. And you know correctly, the minimum and maximum should always be outside the average. Anyway, there's much fun you can have with this sort of thing. And no doubt people predicting stock markets will be very happy to do this sort of thing. But let's briefly go back to some of the other parameters. Let's look at, we looked at the result position, but there's a thing called window weighting. Now this is a way of weighting the number of windowed points. So if in this case it's 20, so this essentially rectangular means anything outside the window is 0, anything within the window is set to the full value. And there are various other functions. Triangular, I assume, must mean that the ones at the extremes of the points are nearly 0. The middle of the data points is set to the full maximum. And there are different shaped functions, and that can, I think, be important when you have some sort of edge effect going on. But I tend not to worry about that. Keep original attribute, that was obvious. If I set that to false, then obviously the original raw data will be removed from the result. And ignore missings. That if there were missing data, then it could get ignored if you set that to true. In this case, there isn't any, so there's nothing to worry about. So let's just run this one more time, and I'll just show some pretty screenshots before the end. So let's, for fun, let's put the average month opening price on the x-axis, and because I can't think of anything else, let's put the yearly on the y. Exciting. And let's colour in with the date. So 1972 is blue, starts here, meanders around here, ends up down here, this at the present day. We'd even put the actual volume in as a size, so let's try that. Let's put the volume for the year in as the size. Okay. So low volumes are small, high volumes are big. Anyway, it's always nice to see pretty pictures. Whether they mean anything is another matter. I'll leave that for others to decide.